Okay, everyone. Just a reminder, next week will be the week number 9. It's the midterm week. I believe most of your courses have their own exams in next week. We have that too. We have 3 classes in a week, and the first class next week. Next week, the first class we will have the lecture as usual, and the second and the third classes, we will have the return. Is it okay for everyone? Sure. If you want to elongate the exam time, you are okay. If you okay, it's so easy. I finish every test questions over there. I can quit a little bit early. Sure, you can do that. You can do that. And again, as I mentioned, you can use any kind of paper, books, notebooks, everything like that. You can use any electronic devices during the exams. I cannot prohibit you to use AI to solve the problems. I cannot, but I don't encourage that. I don't encourage that. Why? Personally, again, you can calculate the standard deviation in few clicks, right? But you need to understand the principles why the early scientists designed this kind of formula, how to calculate step by step. And later, when you handle maybe thousands of data in one time, you know how to do it. But we just practiced with maybe 5 or 10 data, then there's easy model that you can understand the rules. For example, how to get the average, how to get the individual data minus the average, and why do we need to make square value of that? Because we want to have positive value of it, 0 or positive, no negative value. Then you need to take square root, return the square value. But in the denominator, you may need to divide it by n or divide it by n minus 1. So in the future, if you understand those rules, even you don't have a computer, but you understand the rules, you understand the principles, you can calculate by your hand. Even an easy calculator. And in the future, if I give a wrong set of data, then you can find something wrong, something strange. Why? Maybe it's a wrong data with the wrong mean, with the wrong standard deviation, like this. Okay, next week we finish the chapter 6.2. Let's move to 6.3. Let's move. Okay, let's move to chapter 6. Okay, today this part is a little bit hard to understand, but you can get a result in a few seconds, just few clicks. You can use any kind of software or online free application. That is up to you. But I try to explain it slowly. I hope everyone can understand the details of this one. Okay, finding probability from the normal distribution. The empirical rule is just an approximation and only works for certain values. What if you want to find the probability for the x value that are not integer multiples of the standard deviation? The probability is the area under the curve. Okay, let me say it again. The probability is the area under the curve. Okay, I'm going to shut up. I'm going to be quiet for 10 seconds. The probability is the area under the curve. Actually, it's from the integration. Okay. And to find area under the curve, you need calculus. Actually, I know some students are very hate calculus. I know that. But this one, we just check table. Okay. Before technology, you needed to convert every x value to a standardized number called z-score, or z-value, or simply just a z. The z-score is a measure of how many standard deviations an x value is from the mean. Again, what does it mean, z-score? The z-score is a measure of data, one set. How far is it away from the mean, and the unit is standard deviation. Sure, I think this moment someone of you already confused about this one. Okay, to convert from a normal distributed x value to z-score, you can use the following formula. Your z-score, the definition your z-score is z equals, in the numerator, x minus the mean, and divided by standard deviation. So I have a question. Is the z value always positive, or it can be a negative value? That's a question. It can be. After our explanation in the past weeks, we know the sigma, the population standard deviation is always 0 or positive, right? No negative value. But how about the z-score? Again, because do you remember the definition of the standard deviation? The individual number minus the mean, the value can be negative, but negative it makes no sense. Thus, the scientists defined make the subtraction the square value, then take the square root. Thus, the value always to be 0 or positive, no negative value. But how about the z value? X minus the mean. Can it be a negative value? Yes, it can be a negative. So don't be afraid to answer this one. Z-score can be 0, can be positive, can be negative. Why? Because it just want to know the distance away from the mean. The distance away from the mean. But how can we use the distance? That is standard deviation. Okay. Where mu, mean of the population of x value, and sigma, standard deviation of the population of the mean. Okay, let's move. And for this one, standard normal distribution, z has a mean mu equals 0 and standard deviation sigma equals 1. Okay, let me explain this. If I have value, the value I want to find the location on this curve. For example, the value after standardized, it can be here, 0.5 minus value 0.5 is here, and we know the location is here, and the frequency will be here. Okay, for example, assume the average height of Taiwanese. Assume it would be 170 centimeters. Assume for a man, 170. It can be the average, also the most frequency about this body height. And how about the body height about 190 centimeters? 190 centimeters can be it exists. Sure, many people has this kind of height, 190 centimeters, but the frequency is pretty low. It's pretty low. How about a man in Taiwan? Very, very short, about 149 centimeters. 149 centimeters. Sure, maybe the gentleman, the score will be here. -3 standard deviation away from the mean. From the mean. Is it okay? So most of the people will appear the average or the highest frequency of the average height, 170 centimeter height, like this one. How about 180, 190, 195? About here. The population frequency is a little bit, but 170, the frequency is very big, very big. Okay, let's move. Okay, and example, let's try this example. Example 6.3.1, general normal distribution. The length of a human pregnancy is normally distributed with a mean of 272 days with a standard deviation of 9 days. Okay, again, 272 plus minus 9 days. Okay, please state the random variables. A, X equals the length, the days of a human pregnancy. Okay, question B, find the probability of a pregnancy lasting more than 280 days. Find the probability of pregnancy lasting more than 280 days. Okay, let's check here. The probability like this one, according to the curve. Sure, later I will tell you how to do this. When we draw a normal distribution like this one, and the mean is in the center, the symmetric axis here, then we can find 272 here, and about 180, where is the location? 280 days. 280 days is, if 272 plus 9 days, it means 1 standard deviation. That will be 281. So 280 is a little bit smaller than 1 standard deviation. Okay, and find the probability of this one. Look at the picture, realize the low limit, then the upper limit is infinity. What does it mean? The question asks, lasting more than 280 days. How about 281? Yes, it's in the field. 282, 283, 284, 290, 293, 295. So over this value fits the definition. And now how to calculate this? Let me tell you, I don't know. I don't know. Actually, we need a normal distribution to calculate the standardization and calculate the area. Sure, later I will tell you, you just find a free drawing website and type your conditions over there, then you will get the answer in a few seconds. But I will not teach you this first. I will tell you how to find the score first. Okay, and this one. Thus, 18.7, the probability for all pregnancies less than more than 280 days. This is not unusual since the probability is greater than 5%. Again, the pregnancy lasting more than 280 days is not unusual because this value 18.7 is greater than 5%. Thus, we consider is not unusual. It's very popular. I mean, not so popular. It's common. Okay, and how to calculate this? Okay, let me give you, for example, you can find out. Yeah, if we find the z-score table over here, and that's the week. Okay, maybe this one is okay. Let me give you this one. Like this one, okay. Okay, one minute, please. Okay, let me make copy and send it to our group. Okay, please download this file. Please download this file. Oh, no, this one. Okay, are you ready? Download this file. Okay. Oh, who yet to download this file? Are you done? Are you done? Download this file. Okay. Okay. Then now let me explain how to use this. First of all, standard normal distribution table values represent represent area to the left. Again, left of the z-score. To the left of the z-score. What does it mean? What does it mean? Like this one. If I have a normal distribution, like this. Oh, sorry. Like this one. Okay, if I have a score over here, if I have a score here, what does it mean? The area to the left. The area to the left. Okay, we can see it will be like this. This part is okay? Is okay? And sure, during the diagram, this one, the symmetrical one here is the z-score of 0. Z-score is 0. Here is the mean. Sorry, I cannot type it. Okay, I mean, please, maybe I can use this. I can use this. In the symmetrical line here, is z-score is 0, the average is 0. And if I got a score, for example, I got a score is about minus 2.0. Minus 2.0, and the area to the left will be 0.02275. Okay. If this location is minus 2, it means 2 standard deviation away from the center. 2 standard deviation away from the center in the left side equals minus 2. Equals minus 2. And this moment, the area in the green area, that will be 0.02275. Sure, this ugly drawing by my computer, it's not the exact the value, but I think it's a concept very easy to understand. Standard deviation table value represent area to the left of the z-score. Is it okay? And now I want to explain one thing. How about the question here? Let's move back to our question. The first question, find the probability of pregnancy lasting more than 280 days. More than 280 days. And now I want to explain this. Okay, if I have, sorry, not this one. If I have a line here, and then we know the average is here, okay, we know the average is here. How about the average? Sorry, my hand drawing is very horrible. Okay, forgive me. Okay, about the mean, the population mean is 272 days. And we know one standard deviation, that will be 9 days. And we can know how about here. If we plus one standard deviation, 2 standard deviations, here will be 272 plus 1. Here will be 281. But the question is asking you something about this, like this one. 280, and how about the area over this value? If I use the sign like this one, like this one. Okay, who can tell me how to calculate this? First of all, where is the location? Here. How many standard deviation away from the center? We know less than 1, because 272 plus one single standard deviation, 9, that would be 281. But our answer, our question is about 280, a little bit smaller. But who can tell me how to calculate this? Very easy here. This score is the value minus the average, and divided by the standard deviation. Okay, let's try. We say, sorry. Oh, sorry, my hand drawing is horrible, but okay. We say the z-score, that will be the value 280 minus the average 272 and divided by the standard deviation. Okay, sorry, my hand drawing, I forgot to bring my mouse, so forgive me. Okay, how to calculate this? Very easy. 280 minus 272 here is, and divided by how many? How much? 9. And the answer will be 0.8888. Okay, again. Where x is the mean of the population and the sigma, the standard deviation of the population in the denominator. Now I just finished calculation the z-score of 280 days. 280 days, like this one, 280 here. And next step, we need to know the area of this one. But you may feel confused. Why? Hi, Dr. $1. I cannot understand this because it just showed us about why? 1 minute, please. Let me open the file. Okay, you just told us, according to the table, it means the left of the z-score. But according to our textbook, we need to know the area of the right part, not the left part. How can we do this? How can we do this? Yeah, go ahead. Very easy, because the area of all area covered by the curve, the Bayer curve, is 1. Is standardized, is 1. And we can do the other way. When we need to know, okay, let me draw it again. If we have this, if we want to know, oh, sorry. If we want to know the area in the right side, oh, sorry, my hand drawing is horrible. Okay, if we want to know, if we need to know the area in the right side, we just use the area 1 minus the location here and find the value minus the left one. Then we will get the right one. Is it okay for everyone? Sorry, I may postpone the break time. Let me finish this question, okay? Again, so we got, how about we got the value? We got this score. What's the z-score here? That is 0.888. 0.888. Let's check the table. Minus no. Positive, yes, positive. So here is the positive 0.8. How about the second decimal? The second decimal is here. 0.88. Again, let me show you that here. Oh, sorry. Above the first decimal, 0.8, we can find it will be here. 0.8. How about the second decimal? I highlighted here. That will be here. Is it okay? Then we will find the answer. All right. So we get what we get here. Later, I will screenshot this one. I will send this one to our line group. Okay. Let me. I want to treat it like a freshman, like something actually you're a freshman. But I think this part is a little bit hard. But in the future, when we check the t-test table, f-test table, we will use the similar way. Then later I can accelerate. But this time, I think it could be your first time to use this table. Again, we finished calculating. We got the z-score 0.888. But now we cannot use 8. Why? We need to run it to the next decimal. So not this one. We need to write, it will be 0.09. Should be this one. Should be this one. Unless you can get rid of it. So this one is better. Is it okay? Is okay. And then we know the area to the left is 0.81327. But what we need is this one. The area over here, 0.8137. And how about the other side? The total. Oh, sorry, let me screenshot this first. Okay, we know the second decimal is 8, but the third one is 8. We need to run it up to the previous decimal, and that will be 0.09. 0.09. Thus, our answer is 0.81327. Thus, we can, the total area is 1 minus 0.8137. And the answer will be 0.1863. 0.1863. Let's check the answer from textbook. Here, sure, maybe we use different version of the table. Here, 0.187. Sure, don't worry about this. During our exam, the similar number, I will give the correct answer, and I will consider it's the correct answer and give you the score. Don't worry. Don't worry. Again, let's review the question again. The length of a human pregnancy is normally distributed with a mean of 272 days, with a standard deviation 9 days, plus minus here. And the question B, find the probability of pregnancy lasting more than 280 days. More than 280 days. Thus, the first step, we need to find the location, how far away, 280, how far away from the mean 270. Thus, we use the formula here. Z equals in the denominator, in the numerator, x minus mean. Can be positive, can be negative. In the denominator, that is the standard deviation of the population. It's always 0, so it cannot be a 0. Okay, it can be always it can be a positive value. Then we got a calculation. We get this. (280 minus 272 divided by 9, we got the answer 0.88. 888, like this one. Thus, we got a z-score of the 280. And now we check the table. And again, today I will tell you how to use the application. Just type the mean, the standard deviation, and the condition you want to know. You can click it, get the answer. No more than 10 seconds. No more than 10 seconds. But you will not understand why. So I encourage you slow down. I try to slow down my speech and understand the rules here. Again, check the table. The table means the area to the left side. But according to the question from the textbook, we need to know the area from the right side. Very easy. The total area is 1. 1 minus the left side will be the right side. Okay. And we got the z-score 0.88. And we check the table. The first decimal, 0.8, the first 8 here, 0.8. And the second 8 will be here. But the third 8, the third decimal will be, okay, thanks, okay, thank you for the rescue. And the third decimal is 8, and round up to the previous decimal, that will be 0.09. 0.09 will be here. Okay, and 0.09 here, and the answer is 0.81327. What does it mean? The value here means the area to the left side. According to my horrible hand drawing, that would be this. That will be the green area. But we need to find the area to the right side. Thus, we use 1 minus the left, then we will get the right area. So we can use 1 area, 1 minus 0.81327, and the answer is 0.1863. So far, okay? Sure. If you're confused with this one, next class after I check attendance, we can practice the second question, third question. Then I think you understand this part. Sure, this part will be one of the midterm exam, but I will change the number. Oh, any question? No more question. Sorry for postpone the break time. So have a 10-minute break. Okay, see you later, gentlemen and ladies.